Good day, everyone. This is a Group 11, and we are about to discuss the chi-square test of homogeneity. I am the first reporter, Jasa Navarez, so let's start. Chi-square test of homogeneity expands the test for difference into population proportions, which is the two-proportion z-test we learned in inference for two proportions. When to use chi-square test for homogeneity. For each population, the sampling method is simple random sampling. The variable under the study of categorical. If sample data are displayed in a contingency table, the expected frequency count for each cell of the table is at least 5. So, use the chi-square test for homogeneity to determine whether observed sample frequencies differ significantly from expected frequencies specified in the null hypothesis. This approach consists of 4 steps. First, state the hypothesis. Second, formulate an analysis plan. Third, analyze sample data. Fourth, interpret results. State the hypothesis. Every hypothesis test requires analysts to state a null hypothesis and an alternative hypothesis. So, state the hypothesis in the test of homogeneity. Select a random sample from each subgroup or population separately and collect data on a single categorical variable. Formulate an analysis plan. Significance level. Often researchers choose significance level equal to 0.01, 0.05, or 0.10, but any value between 0 and 1 can be used. Used the chi-square test for homogeneity to determine whether observed sample frequencies differ significantly from expected frequencies specified in the null hypothesis. So, the analysis plan describes how to use sample data to accept or reject the null hypothesis. Used the chi-square test for homogeneity to determine whether observed sample frequencies in the null hypothesis. Next reporter.
So, hello everyone. I'm Flora May Zabati, so let's continue. So, analyze sample data. To analyze sample data, we use the formula df, or degrees of freedom, equals quantity r minus 1 times quantity c minus 1, where r is equal the number of populations and c is equal to the number of levels for the categorical variable. Next is the expected frequency counts are computed separately for each population at each level of the categorical variable according to the following formula. So ERC equals quantity NR times NC over N, where ERC is the expected frequency counts for population R at level C of the categorical variable, and NR is equals the total number of observations from population R. NC equals the total number of observations at treatment level C, and N is equals the total sample size. Next is the test statistic. So the test statistic is a chi-square random variable, or x squared, defined by the following equation. So x squared equals the sum of quantity ORC minus ERC squared over ERC, where ORC is the observed frequency count in population R for level C of the categorical variable, and ERC is equals to expected frequency count in population R for level C of the categorical variable. The p-value. The p-value is the probability of observing a sample statistic as extreme as the test statistic. Since the test statistic is a chi-square, use the chi-square distribution calculator to assess the probability associated with the test statistic. Use the degrees of freedom computed above. Interpret the results. If the sample findings are unlikely, given the null hypothesis, the researcher rejects the null hypothesis. Typically, this involves comparing the p-value to the significance level and rejecting the null hypothesis when the p-value is less than the significance level. So this is the p-value table. This will help to interpret the result. And the next reporter will show you some examples.
Hello everyone, this is Kabatino Sam, and I'm about to give you the first example for the chi-square of homogeneity. The first problem is, a teacher selects a random sample of 100 high school students. 60 are right-handed and 40 are left-handed. The students were asked about their preferences about math and English. So this is the table for the first example. The total number of participants is 100. 40 students are left-handed and 60 students are right-handed. 30 of them love math, 15 love English, and 15 view them equally. 10 among the left-handed students love mathematics. 25 of them love English and 5 of them view them equally. For the total number of 60 right-handed students and 40 left-handed students. So this is a total of 100 students. So next, we must state the hypothesis. The null hypothesis is that there is no difference between in subject preferences for left and right-handed students. The alternative hypothesis is there is a difference. Formulate an analysis plan. So as you can see, the total of right-handed students is 60 and the total number of students who love mathematics is 40. 40% of 60 is 24. 40 students love English and 40% of 60 is 24. And 20% of 60 is 12. So for the left table, 40% of 40 is 16. 40% of 40 who love English is 16, and 20% of them is 8. So the total number of right-handed students is 60 and the total number of left-handed students is 40. So the table in the right side is the expected. So for this part, we are going to get the degrees of freedom and the chi-squared with its formulas. So the formula for the DF or degrees of freedom is R minus 1 multiplied by C minus 1, where R is the number of row and C is the number of columns. For the chi-squared, the formula is observation minus the expected squared over expected. So as you can see, the total number of right-handed students who love mathematics is 30 and the expectation is 24 and so on. So our degrees of freedom is 2 and the chi-squared is 3.75. Next is to interpret results. So with the use of the degrees of freedom and the chi-squared, we will be able to find the critical value, and if the critical value is less than the significance level of 0.05, we will reject the null hypothesis, or we will fail to accept the null hypothesis. So as you can see, our degrees of freedom is 2 and the chi-squared is 3.75. So 2 and 3.75 is between 0.90 and 0.10, which is greater than the 0.05. So the critical value is greater than 0.05, which is the significance level. We will accept the null hypothesis. For the conclusion, the p-value is greater than 0.05, so we accept the null hypothesis that there are differences between subject preferences among left and right-handed students. So we accept the null hypothesis. And the second example will be discussed by the next reporter.
Hi, good day everyone. I am Honey James Punya, and I am going to explain and discuss our second example on how to solve for our chi-square test of homogeneity. So next example is, suppose you are interested in knowing whether the distribution of income classes, which is the low, middle, and high, are the same for males and females in your state. State siya, you take a random sample of 500 males and 450 females from your state. You determine the income level of each individual. So, as shown on the table, we have 109 samples of male in our low income, 365 samples of males in our middle income, 26 samples of male in our high income. So total male sample are 500. Next is for our female, we have 192 samples for our low income, 249 samples for our middle income, 9 samples for our high income. So total females, are 450 samples. So for our total low income samples, we have 301. Middle income samples in all are 614. High income, we have 335. So our total of sample, or our total sample size is 950. Next is for our solution. First thing to do is state our hypothesis. So for our null hypothesis, we have here that there is no difference among the male and female distributions of income. For our alternative hypothesis, we already know that alternative hypothesis is the opposite of our null hypothesis. So our alternative hypothesis is there is a difference among the male and female distributions of income. Next is formulate analysis plan. In my case, I am going to use the significant level of 0.05 in conducting or solving for our chi-square test of homogeneity. But it is also okay to choose 0.01 or 0.10. It's just dependent on the researcher. Anyways, the answer is still the same. Next is to analyze sample data. First thing to do is to solve for our degrees of freedom. So the formula of solving our degrees of freedom is df is equals to r minus 1 times c minus 1, which means r is the number of population and c is the level for the categorical variable. According po sa akong natanaw nga video about sa chi-square test of homogeneity, to fully understand and to determine our R and C, R is also refers to the rows in our table, and C refers the column in our table. So R we have 2 minus 1 and C is 3 minus 1. So our degrees of freedom is equals to 2. Next is solving for our expected frequency count. So the formula in solving our expected frequency count is equals to E sub R and C equals the quantity of n sub r times n sub 2 divided by n, which means that the expected frequency count for population R at level C of the categorical variable is equal to the quantity of n and R, which means the total number of observations from population R times the total number of observation at treatment level C divided by our total sample size. So for our population R1 and level C1, this one, so we have 500 total males sample times 301, which is the total low income from male and female, divided by 950, which is the total population of our male and female from these three classes of income is equals to 158.4. Round off, we have 158 for our first expected frequency count. Next, in our population R1 level 2, this one, we have 450 females times 301 total low income divided by 950 is equals to 142.5 or 143 round up. Next, R1 level 3, this one is equals to 500 total males times 614 for our total middle income from both male and female divided by 950 total sample size is equals to 323.15. Round off, we have 323. Next, for our R2 level 1, we have 450 females times 614 middle income total from male and female divided by 950. We have 290.8 or 291. Round of yapon siya. As in, we are going to have our expected frequency count into a whole number. Next is E sub population 2 of level 2, we have 500 males times 35, which is the total high income from male and female divided by 950 is equals to 18.4 or 18. Next is the R of 2 level 3 is 450 females times 35 total high income divided by 950 is equals to 16.57. Round off, we have 17. So in this table, this is our expected frequency count of our given problem. Next is to solve for our test statistic. So the formula for solving our test statistic is the the square root of the difference of ORC minus ERC, which means ORC is the observed frequency count in population R for level C minus ERC is means the expected frequency count in population R For level C, katong natong gisolve, so mo ni siya. Next, divided by ERC. So we have, so in our given, we have 109 low income for male minus 158 for our expected frequency. Then open and close parenthesis, square na to na siya, divided by 158. Plus, 300, the squared of 365 for our middle income of males minus the expected frequency of 323 divided by 323 plus the square root of 26 high income males sample minus 18, which is our expected frequency, divided by 18 is our expected frequency also, plus 192 for female low income minus 143 expected frequency. So don't forget that after na siya square jod after ang answer sa kanang duha ka given. Divided by 143 plus the square root of 249 middle income female minus our expected frequency, which is 291 divided by 291 plus the square root of our high income females, which is 9 minus expected frequency of 17 divided by 17. So our answer for this is 15.2. An answer for this is 5.5. Our answer for this is 3.6. Our answer for this is 16.8. Our answer for this is 6.1. And the last one is 3.4. So if we are going to total this all, we can get the 50.6 for our test statistic. So p-value is the probability of observing a sample statistic as extreme as the test statistic. So our p-value is greater than 50.6. So in our table, I am going to locate our 50.6 with with the corresponding degrees of freedom, which is katong itong natong nakuha. So atong degrees of freedom kay 2. 2 no. So pangitaon na to diri asa si 50.6. Our last number here is 10.597. So wala naman siya kanang karugtong diri nga kuano kanang degree kaning alpha. Wala naman siya karugtong alpha, so which means that adili ta mo stop sa 10.57. Mo ni siya ay 597. So kani siya atong gamiton nga alpha. Mo ni atong nakuha nga test statistics is 0.05. So in our conclusion, so di ba ang atong gigamit nga significance level kay 0.05. Nya atong nakuha sa test statistic kay 0.005. Okay? 0.05, yes. Because mo siya katong kinalasan nga number nya wala kita kako sa 50.6. So because the p-value is less than 0.05, we reject the null hypothesis, which is there is no difference among the male and female distributions of income. So I hope guys you get something from our report. You learn on how to solve for a chi-square test of homogeneity. If you have any clarifications and questions, you can reach out from these reporters because we are willing to answer your questions and teach you on how to solve for a chi-square test homogeneity. So that's all. Thank you.